Okay, so welcome to my video on t-scores. In my last video, I talked about the letter Z and how we use z-scores and how we use the z-test. And many people get confused on when to use the z-test and when to use a t-test. So I wrote for you some conditions that let you know when you need to use the t-test. Okay, and I wrote these for you here on the screen. And the first one is the population standard deviation is unknown. Okay, that is our first condition for using the t-test. Our population standard deviation, which is the Greek letter sigma, is unknown. We don't know what it is. And the second condition is the sample size is less than 30. Okay, the sample size is always written with the letter n, and it is less than 30. Okay, so both of these conditions need to be met to use the t-test. Our population standard deviation is unknown, and if the sample size is less than 30, both of those conditions need to be met. Then we need to use our z-test. And I'm going to talk about these conditions a little bit more once we get started with an example, and I think it'll make a little bit more sense. Okay, so here we have a t-test example, and it says that the average test score of a population is 75. Okay, so we know that the average for the population, which is always written with the Greek letter mu, is equal to 75. So they give us the population average, but they do not give us the population standard deviation. Okay, so the population standard deviation is unknown. Okay, and it also says that a sample of 9 students are randomly selected. Okay, so we have a sample size of 9. So our sample size n is equal to 9, and it also says that the standard deviation for the sample is equal to 10. Okay, so the standard deviation of the sample is always written with the letter S, and that is equal to 10. So now I want you to notice why we're using our t-test. Our population standard deviation is unknown, and our sample size is less than 30. So these two conditions force us to use the letter T instead of the letter Z. Okay, so now let's take a look at what this question is asking us. It says, what is the probability that the average score for the sample is above an 80? So the average for the sample, which is always written with the letter X with a bar above the X, the average for the sample is equal to 80, and it's asking us what is the probability that the average is above 80. Okay, so let's draw everything on the curve. We know that the population average is equal to 75, and that always goes directly in the middle. So the average for the population always goes directly in the middle of the curve. And we know that the average for the sample is equal to 80. So since 80 is greater than 75, I'm going to place that value of 80 anywhere above the value of 75. So I'm going to draw a line anywhere above 75, and I'm going to place my value of 80. And this question is asking us, what is the probability that the average for this sample is above 80? So we need to find the area above 80, and that will give us our answer. Okay, so since we're doing a t-test, let's find our t values. And before I do that, I'm going to erase everything here on the right. So we know that the t value for the population average is always going to be 0. So this population average of 75 has a t value of 0. So now let's find the t value for this value of 80. And we could find that using this formula. The t value is equal to the average of the sample minus the average of the population all divided by the standard deviation of the sample divided by the square root of the sample size. So if we plug everything into our formula, we have t is equal to our average of the sample, which is 80, minus our average of the population, which is 75, all divided by our standard deviation of the sample, which is 10, divided by the square root of our sample size, and our sample size is equal to 9. And if you plug all this into your calculator, we get a t-value of 1.5. Okay, so we know that our sample average of 80 has a t-value of 1.5. And we can use this t-value of 1.5 to find this area in red, or the area of this tail. And in order to find this area, we need to use a t-table. Or if you don't have a table, you can use a t-calculator. And I like to use a calculator because it's much quicker. So that's what I'm going to do. So here we have a t-calculator to find that area of the tail. So we can just plug everything in. Our t-value is equal to 1.5. And our degrees of freedom is always going to be 1 less than our sample size. So our degrees of freedom is going to be 8, because that is 1 less than our sample size of 9. And then once you plug that in, you can just click calculate, and we get the area of one tail is 0.06002. Sorry, 0.086002. The area of two tails is just double that. It's 0.172003. So we're only finding the area of one tail, so we need to use this value right here. I'm going to round to 4 decimal points, 0.0860. Alright, so we know that this area of one tail is 0.0860. Okay, so now we have everything we need to answer this problem, and I need a little bit more space, so I'm going to erase this here on the right. So once again, this question is asking us, what is the probability that the average for the sample is above 80? So what is the probability that the average for the sample is greater than 80? And we know that this is equal to the area in red, the area above 80. And we know that the area in red is equal to 0.0860, or you could say 8.60%. The probability that the average for the sample is greater than 80 is 8.6%, or you could say the probability that t is greater than 1.5 is equal to 8.6%. So I hope this gave you a better idea of t-scores and using the t-test. And in my next video, I'm going to go over some more examples of when you should use a z-test and when you should use a t-test. So I hope you're enjoying these, and I will see you in my next one.